In general, when we do time domain analysis of a parallel bus system using Topology Explorer System SI tool, it displays variations of all the signals in the memory and controller by default. However, we use voltage and current probes if we wanted to see specific data and data strobe signals. In this video, we will define voltage and current probe points for DQ and DQS and set up sweep analysis parameters. So let's get started. In the first step, we'll open the project file, which you can download from the link given in the description. Then run the Topology Explorer 22.1 from Cadence program menu. Select Advanced SI2 license. Then you can open the file, which will be SPBS 1C DDR4, and click on Open button. Once the project file is open, we can go to Setup and select Probe Points from the Setup menu. And as you can see, Probe Points window will open. Now here we are going to add probes. So first, make sure you have selected the voltage tab and click on Add Probes button. And here we are going to add probes on DQ0. So make sure you have selected that. Once you do that, a positive sign will appear on this column. And next you have to assign the negative probe to the VSSQ. Then we'll click on this arrow to move these to the right window. And as you can see, the positive probe is assigned to DQ0 and negative probe is assigned to VSSQ. Next, we are going to assign the probe for W block, which is our transmission line. So we are going to change block name to W, connection to right, and from here, let's short these net from increasing order for a DQ signal. Then we'll assign positive node to DQ0 and negative node to ground. Then move it to the right window, and here we go. We have assigned another probe point on this circuit block. Next, we are going to assign a probe point for tuning block. So let's select tuning block from block name, connection type to right, and we are going to add for the same signal, which is DQ0. Let's assign positive node here and negative node to VSSQ. Move it to the right window. And here we go, we have assigned 3 voltage probe points for this circuit block. Now if you wanted to verify all the voltage probes, you can click over Show All Probes button, and here we can get all the probes for a particular circuit. Alright, now we can close this window. In order to observe time varying current through signal nets between any of these two blocks, we can define current probes. To do that, you have to right click over any of these wire, then click over Add Current Probe button, and the current probe points window will open. Now make sure you have selected the correct connection between controller and W block. Then let's short this table. So we are going to assign the current probe on the DQ signal. We'll select it, right click, and click over Add Probe. So as you can see, this red marker will be added here. Next, we are going to assign the current probe between tuning block and memory. So let's select that from connection, select the DQ signal, right click and add probe. And similarly, we are going to assign the current probe between W and tuning block and add probe. Alright. To see all the 3 probes in a window, we can click over Show All Probes. And from here, we can verify we have assigned the correct probes. After assigning the current and voltage probes, we can close this window. Now in the next section, we are going to set up sweep parameters for different values of propagation delay. Now to do that, you have to go to Tool and select Sweep Manager from here, and Sweep Manager window will open. Now in the Sweep Manager window, we'll select the parameter type to SPICE model, and make sure you have selected the parameter bullet from here. Block should be tuning block. And here we'll find the propagation data option in the name column. We'll select that, right click and click over Add button. Once we'll do that, we can see as of now, the propagation data is set for 500 picoseconds. Now we are going to change it for 3 different values between 300 and 700. So let's set the minimum value for the propagation delay is 300 picoseconds. Maximum value 700 picoseconds. The increment steps we want between 300 and 700 is 200. Alright. So that means it will have 3 counts. Alright. So let's hit enter, and as you can see, we'll have 3 counts which will be 300, 500 and 700 because it has 200 increment on each step. So we have set the sweep for propagation delay in DQ signals. So that's it for this video. We can close this window and save the project. In the next video, we will run the simulation and see 2D plots and reports. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.